Supplemental math videos from Circle Christian School. What makes a parabola? Well, you have things like a vertex, a maximum, a minimum. It's got a curved shape to it. It's very symmetrical. Basically, something happens squared and then finds its way back down or its way back up. Depends on if you're bouncing the ball or throwing the ball up in the air. We have our general form of a quadratic equation, ax squared plus bx plus c. A, b, and c are real numbers. And that's the one we use if we really just want to solve for x here. And then we have our standard form, also known as vertex form, which tells us where the little guy's hanging out at. Okay, there's parts to all this. Remember, you've got your h and you've got your k. But the big thing is, what is x doing? Well, the power tells you what kind of shape it has. Remember that an x squared gives you that cute little parabola. When you have an x to the third power, it's got the drop parabola. And then anything with an even power to it, for instance, if you've got x4 or maybe 6 or 8, just means that the parabola has little things going on inside of it. Likewise, when you've got the odd powers, x to the 5th, the 7th, and the 9th, you have that little cubic thing with stuff happening inside of it because there's stuff in the middle. Let's find the standard form of an equation that has a vertex and it has a point on the parabola. With these, to find the equation of a quadratic, you need to have two things. You need to have a vertex and you need to have some sort of point. It can be a y-intercept or it can just be a point on the parabola. So basically what you're going to do is go back to your standard form, which is that y equals a x minus the h. This tells us that it's a parabola, and then the h and k tells us where it's hanging out at. Well, we replace the vertex numbers inside here, which gives us the equation here. And the next thing that we replace is the x and the y. Because what we need to do is find that a, that scale factor that tells us if the parabola is positive or negative, skinny or wide. And you just use the real numbers to determine what a is and then put it back into the equation, which you'll notice happens right here. And then if you have to change it back into general form, because for some reason they want you to put the parabola back into the cake box, then you're going to have to do the FOILing out. Make sure that you do the squared part first, exponents, before you do any multiplication or adding. And that will give you the equation in the finest. Both of these types of equations, whether it's in standard form or general form, will allow you to put it into a calculator and also take a look at it. Graphing an inequality parabola. Well, it means we've got those greater than and less thans and things going on here, and we're just looking for all the possibilities. To graph these, what you're going to look for are the critical numbers. These are the important numbers. Basically, you're going to solve for x, and that's going to tell you where you can make good test intervals. So once you find the critical numbers, you just set them up to where it begins, what's happening in the middle, and where it ends with the parabola. And then you have to figure out what works. So are the points on the inside of the parabola or on the outside of the parabola? Just make your tests and figure out what's true and what's false. Another way that you can do it is just really by looking at the inequality and what it's saying. This one's a little bit tougher because sometimes they put the y at the front, or they'll put the y instead of being at the back, so you can look at it that way. Remembering that if the inequality doesn't have the line underneath it here, then you're going to have a dotted parabola. And if it does have the line here, then you have a solid parabola, because it means it includes all the points that are also on the parabola. So as I look at the first one here, it says that y is greater than the parabola. So I take a look at the parabola here and start looking at my y-axis and find all the ones that are big. I can see it's inside the parabola here. On the other one, it says that the y is smaller than the parabola. So I have to go to the parabola here, look at my y-axis, and see all the ones that are smaller, and that shows me that I'm going to shade on the outside. All else fails, just make a test.